All right, check this out. This Lamborghini can hit 60 miles per hour in only 2.6 seconds. Thank goodness for the cameraman that he got out of the way. So let's look at this. Today we're working on 11.3, the tangent line problem, on page 174 of your note guide. This is the beginning of what calculus really is. We're going to be talking about differential calculus, where we will be looking at instantaneous rate. So that car, if we were to look at its average velocity, this is a problem that you're very familiar with, where we would be looking at the change in position, so the car's distance, over the change in time. So this delta symbol here stands for change. So change in position, S stands for position, over change in time. So to do this, this is a simple slope problem, or average rate of change problem. And you would take the car's distance, and it says that the race car drives a quarter of a mile in 4.5 seconds. So if we do a quarter of a mile, that's 0.25 miles, and we divide that by the car's time, which is 4.5 seconds, then we know that the car's average speed is going to be 200 miles per hour. Down below, I'll show you how I got 200 miles per hour. I did 0.25 miles per second. I need to change seconds to minutes. So in 60 seconds, there is 1 minute. So seconds now cancel. And then I'm going to change minutes to hours. So in 60 minutes, there is 1 hour. So the minutes canceled. And then you can see that when now I have miles per hour, and this ends up giving me the 200 miles per hour. So here's a graph of the average velocity of the car up over here. And what I want you to notice is the Y value is standing for the distance the car traveled. So this is delta Y. And the X value is standing for the change in time. So this is how long the car traveled. And so here's the car. It started, it went over 4.5 seconds. Here's where the car ended, and I was able to find its average velocity. That's a simple slope problem. So change in Y over change in X. We did Y2 subtract Y1 over X2 subtract X1, and that gives me the change in position, or the distance over the change in time. Now, my question to you is, when we watched that video, we saw that the Lamborghini almost hit the cameraman. Remember, the cameraman jumped out of the way. If you don't remember, rewind and watch the video again. So my question is, how fast was the car going when the cameraman jumped out of the way? So we know that this car that we're talking about here, over 4.5 seconds, it went an average of 200 miles per hour. But how fast was the car going at 1 second, at 2 seconds, at 3 seconds, at 4 seconds? How fast was the car going? And this is what we refer to as instantaneous rate. And instantaneous rate is differential calculus. So we know that a linear function has a slope. Our slope is just our rise over run. And our slope is constant with a line. So the question as we start thinking about calculus is, does a parabola have a slope? And so if we were to zoom into the point right 2 and up 4, if we were to zoom in really, really, really close to that point, it would appear to be a line at that place. And so a slope of a parabola does exist. It's just that the slope is always changing. The rate is always changing. And so if we come down here and look at rate of change, in linear equations, the rate of change is constant. It's the slope. If I were to take a curve, so here's a curve, and I wanted to know the slope at this exact point right here, I could draw a tangent line to that point, and if I know the slope of that tangent line, then I will know the slope at that exact point on the curve. Now I just want you to look at this graph, and I want you just to look at the tangent line and look at point A, and I want you to see as this tangent line is moving along the graph, do you see how the slope is always changing? So let's just watch this line. Now the slope is going in another direction, and you can see that that slope is changing as it moves across the function. So what I want you to do is look at this picture, and I want you to look at the orange line, which is the secant line. And in order to find the slope of a line, we need 2 points. So do you see how I'm starting with this orange line? I have 1 point here at A and 1 point here at B. And what I'm going to do is I'm going to bring point A and point B closer and closer and closer together until I end up, the points are so close together that I end up with 1 point, which I'll consider the tangent point. Pierre Fermat is the mathematician from France who came up with this idea of differentiation. So what's going to happen is you can see here's my curve, and I've drawn a secant line, and I've got 2 points on that secant line. I've got a point here and a point here. Now the distance between those 2 points we're going to refer to as h. And if you look at the second picture, you can see that these 2 points have moved closer together. So what's going to happen is these points are going to continue to move closer and closer and closer together until they're so close together that it almost looks like there's just one single point. If I refer to point P as x and f of x, then point Q is going to be x plus h and f of x plus h. So now if I want to find the slope of these 2 points, I could call this x2 and y2, and this as x1 and y1. And so to find the slope, it's the change in y. So do you see how I would have f of x plus h subtract f of x, which is what we see right here, and then the change in x, which would be x plus h subtract x, which is right down here. And then when I simplify that, I get f of x plus h minus f of x over h, because the x and the opposite of x canceled. So we just found the formula for the slope of that secant line. And this might look really familiar as we have been using this function for this moment in time all year long. So you guys remember that we've done find if f of x is equal to x plus 3, find f of x plus h minus f of x all over h. That's something that we've been doing all year. So the reason why we've been doing that is we have been building up to this point to look at how to find the derivative or how to differentiate. So the slope of the tangent line, and the reason why I can say the slope of the tangent line and the slope of the secant line are the same is because what's happened is these 2 points, the distance between those 2 points has approached 0. So I will write the slope of the tangent line as a limit. It's the limit as h approaches 0, that's the distance between the 2 points, is going to be f of x plus h minus f of x over h. Here you can see I drew the function y equals 3x plus 5. So I started at 5. I did rise 3, run 1, rise 3, run 1. And if you look at example 2 on page 121, it's asking you to find the slope of the line at point 211. So point 211 is right here. And if I wanted to know what the slope of the line there, it's the same as the slope everywhere else on the function, which is 3. So the slope, or the rate of change, is 3 at this point and actually at every point on the line. So I can just look here. Here's the slope. The slope is 3, and that's the same as the rate of change. So now, even though we know that the slope is 3, because the function is linear, let me show you how you could actually use this formula to find the slope in a different way. So we're going to use this formula right here, and we will get 3 again, but let me show you how this formula works. So let me get my pen. I have the limit as h approaches 0, and then I have f of x plus h. So everywhere I see an x, I'm going to put in x plus h. And we've, again, worked on this all year. So I have 3 times x plus h plus 5. And then I'm going to subtract f of x. And f of x is 3x plus 5. Make sure you put the whole thing in parentheses. All over h. Now, if you look at this, I cannot use direct substitution because if I plug in 0 for h, I'm going to get 0 at the bottom of a fraction. So I'm going to go ahead and reduce the top. So it's the limit as h approaches 0 of 3x plus 3h plus 5, subtract 3x, subtract 5 over h. So let's see if anything cancels. It looks like that the negative 3x and the positive 3x will cancel. The positive 5 and the negative 5 will cancel. And now I just have 3h over h. So if you have the limit as h approaches 0 of 3h over h, do you notice that we can have the h's cancel? So therefore, the limit as h approaches 0 is simply 3. And we knew that because 3 was the slope of the line, which is the rate of change. And that rate of change is going to be the same no matter where you are on the linear function. So now we're going to use this formula to find the slope of the tangent line in a quadratic function. So now it's going to become quite powerful because a quadratic function, the slope is always changing. So I drew this the best I could on here. But the question is, if I go right 2 and up 3 on this function, at that exact point, what is the rate of change? And so I'm going to use a tangent line, and so this tangent line through that point, if I can find the slope of that tangent line through that point, that looks horrible, then I will be able to tell you the exact rate of change at that exact point, which is called instantaneous rate of change. So I'm focusing in on when x is 2. So here's my formula, and we're going to go ahead and find the limit as h approaches 0 of f of x plus h. So here is my function, and I'm going to find f of x plus h first. So this is going to be 2 times x plus h squared, subtract 3 times x plus h plus 1. We're going to subtract f of x, which is that whole function, 2x squared minus 3x plus 1. And we're going to put that whole thing over h. So now we're going to go ahead and simplify that. The first thing we're going to want to do is multiply x plus h times x plus h. And this is going to equal, I'm going to keep the limit, so the limit as h approaches 0. X plus h times x plus h, that's going to give me x squared plus 2xh plus h squared, and we need to multiply that whole thing by 2. So now I will have 2x squared plus 4xh. Try again. 2x squared plus 4xh plus 2h squared. Now I'm on this part right here. Subtract 3x, subtract 3h, plus 1, subtract 2x squared, subtract 3x. Ooh, no, that's plus 3x. Subtract 1, all over h. So let's go ahead and cancel like crazy and see what we have. So the 2x squared and the negative 2x squared cancel. The negative 3x and the positive 3x cancel. The negative 1 and the positive 1 cancel. And I think that's all I see. So let's write what I have left. This equals the limit as h approaches 0 of 4xh plus 2h squared minus 3h all over h. And you can see that I have a common h in the numerator. So let me see if I can get some more. So you can see I factored an h out right there. And once I factor the h out, it will cancel with the h in the denominator. And so now I'm able to use direct substitution by taking 0 and plugging it in for h. So this will leave me 4x plus 2 times 0, subtract 3. And that gives me 4x subtract 3. Now, if I want to know the slope then of this tangent line here at exactly 0.23, then I am going to take 2, which is the x value, and I'm going to plug it in for x, and that's going to give me the exact slope at this point right here, or the exact rate of change at that point right there. So this will give me 4 times 2 subtract 3, and 8 subtract 3 is equal to 5. So the exact rate of change at this point is 5. So now we're going to finish up. Derivative is simply the process of finding the slope of a tangent line. We can call this differentiation. Differential calculus, we study the rates at which quantities change. We'll be looking at derivatives to find the maxima and minima. We can use it in natural phenomena, displacement, instantaneous velocity. It's used quite often in physics, and it's really quite powerful. So derivative, another way to note derivative is to use this notation here, which you read as f prime of x. F prime of x is equal to this formula that we learned today. And basically, it's just the formula for the slope of a tangent line. So here's some other notations. F prime of x, y prime, dy over dx you see quite often. So those first three are the ones that I see the most of. Example 4, find the derivative of f of x equals 2x squared. So we're going to use our slope formula. So f prime of x is equal to the limit as h approaches 0. And then I have 2, here's the 2. In place of x, I'm going to put x plus h. So that gives me x plus h squared. And then subtract f of x. F of x is 2x squared. See, subtract f of x all over h. To simplify this, we'll do the limit as h approaches 0. Up here, I went ahead and just multiplied this quickly for you. So I did x plus h times x plus h and then multiplied it by 2. So now I have, let me get my pen back, 2x squared plus 4xh plus h squared. Subtract the 2x squared all over h. Let's cancel. Negative 2x squared and 2x squared cancel. I'm going to be able to factor out the h in the numerator. So the limit as h approaches 0. Factor that h out, which gives you 4x plus h over h. Now the h's will cancel. And I can take that h and replace it with 0. So after direct substitution, my answer is simply going to be 4x. Now, I would use 4x to find any point, the instantaneous rate of any point on this parabola. Because they didn't give me the point, I just found the derivative. So the derivative is 4x. So in example 5, we're going to find f prime of 3 if f of x equals 2x plus 4. So we're going to go ahead and use this same limit formula again, and we're going to find f prime of 3. So that means that the a, f prime of a, the a is 3. You can do this problem just like you did on the one above, or you can actually plug in the 3 as you go. So the limit as h approaches 0, and then let me remind you what f of a plus h means. That's everywhere in function f that I see in x, I'm going to plug in a plus h. So I have 2, then I'm going to plug in a plus h. I'll go ahead and put in 3 right now. So a is 3 plus h. And then don't forget, you still have the plus 4. Subtract f of a. So make sure you use parentheses here. And then you're going to do f of a. So that's 2. And then in place of x, you're going to put in a. And a is 3. So that's 2 times 3 plus 4. This is going to give us 6 plus 4, which is 10. So let's simplify. The limit as h approaches 0 of 6 plus 2h plus 4 subtract 10. All over h. Here's the h up here too. Got it. All right. You can see that when we cancel, we'll end up with just 2. So that means that f prime, let me get my pen going. So I canceled all these out. I ended up with just 2. F prime of 3 is equal to 2. Now that shouldn't have surprised you because this was a linear function And so a linear function, you know that the rate of change is the slope. And the slope here is 2, and f prime of 3 is also 2. So obviously we wouldn't use this big formula to find that, but it's useful to know and to practice on linear functions so that you can use them on other polynomial functions that don't have a constant rate of change.